Hello, 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 everyone, and a huge thank you to joining us today for today's panel. This is a lead dev online panel discussion created in partnership with Octopus Deploy, one of the cutest of the mascot animals. This discussion will last about roughly 45 minutes, after which both myself and the panelists will head over to the lead dev Slack to answer some of your questions in the panel Q&A channel. For those of us joining us live, I'm about to drop a link in the chat. The Slack isn't just for these live events. It's just a really great community of engineering leaders and staff engineers supporting and learning from each other. And at the speed of AI, there's more to learn about, right? Constantly. And speaking as a journalist, we all need to share our lessons learned better. So we may have time to answer a couple of questions live. So please do submit those through the Q&A feature on Zoom. And I'll sprinkle them throughout if they are topical. So thank you so much. So I'm not going to lie. Part of what we're talking about is things you've heard before. After all, certainly the people on this call have been banging on about engineering best practices for over a decade now. But now there's just very much more code to consider being written and released by non-humans. Is that an acceptable term for AI? We'll see what they say. So today we are going to talk about how to do it safely. Not all easy solutions, but if you don't do them, your business and your end users will surely lose. Plus, now's a good time to implement all those continuous delivery platform engineering, testing, behavior-driven design, and user-centric best practices that you've been putting off because you don't have the budget for them. But now, if you say it enables AI, you may get the budget. So let's just get started with some introduction. That's my new theory right now. Just say it's for AI and you'll probably get the budget, especially people's jobs. My name is Jennifer Higgins, and I'm your favorite freelance tech journalist, including with lead dev. Today, I'll be joined by Heidi, Jean, and Dave, ready to share their experiences and insights. And remember, we all have a lot of experience in the call, but everyone's kind of a novice with AI agents. We're still newbies or noobs, as maybe the kids don't say anymore. So can you please each introduce yourself and briefly say, what do you think the title question, what safe production changes with AI agents even means? Dave, I'll let you go first for this one.
Okay. Hi, my name is Dave Farley. I'm a consulting software engineer. I say that because it's an internal joke because I like Sherlock Holmes and he was a consulting detective. I'm like everybody else, I'm fascinated and interested in what the future of our work looks like. I think it's changing profoundly. And maybe because I'm a grumpy old man, or maybe because I've just seen a bunch of things, I think that what we are seeing is a deeply profound changing that's saying some of the fundamentals are still fundamentally important. And there are important ideas that we've learned about how to do a good job of software development safely that are even more important now than they were before.
Fair enough. Yeah. And will they still be ignored? We'll see. Jean, I'll let you go next.
Hi, I'm Jean Duplessis. I'm an engineering leader, and I've been in the industry for over 20 years. Not as much as Dave, but I've got a little bit of gray developing already. I have spent my whole career in startups across a variety of industries, and currently work at Kilo, where we're building a platform for agentic engineering. And specifically over the last 18 months, I've been focused on helping engineering teams adapt to agentic engineering practices. In terms of what safe production changes with AI agents look like and what I think about that, I think your chance of success to use AI agents to safely take changes in production is wholly dependent on how safe it was for humans before you introduced agents. I think there's this common saying of AI amplifies everything in your software development lifecycle, and if the cracks were there before the agents, they will continue to be there with them. So we'll see how this evolves.
Absolutely. Cracks to chasms right now. Heidi, please introduce yourself.
Hi, I'm Heidi Waterhouse. I work at Octopus Deploy, and I have been going on for years about how deployment and release are not the same thing. For the love of God, please learn to disambiguate those. And I think one of the interesting things is that we really need to define safe. Does that mean there are never any mistakes, or mistakes are small and tightly scoped and easy to fix? Because I think aiming for perfection, while a good goal, is just going to make you crazy. Whereas aiming for affecting the fewest people possible with the smallest possible mistakes is the best failure mode.
Fair enough. And failure modes are abound. Just nobody's talking about it. Everyone's talking about their percentage increase of productivity that is warranting so much change that's not happening for the end user. So yeah, last year's DORA report echoed what we kind of all knew in a way, but really gave solid feedback and statistics that AI is an amplifier of everything, the good and the bad, the ugly. If you were already what DORA calls a high-performing team, AI enables speed safely at scale. If you were less than that, we'll call it, you're not a failure, you're just learning. It's just more code shoved into the pre-existing bottleneck. So I want to start off with popcorning, which pop, 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 just everybody call out what the many things that you believe create stable systems are, and that are even more important in the age and speed of AI and agentic AI. Just jump right in. What do we got?
Working in small steps.
Scoping, yeah,
Yeah. Easy rollbacks.
easy rollbacks.
Specifying what we want and verifying that we get it.
Incremental deployments.
Keeping things, yeah, no, that's the same as Dave. Never mind. Small. Keep it small.
Yeah.
Good observability.
Yeah. It's across the board. It's all of the, we're starting to iterate and repeat ourselves, because across the board, what we need to do is that we need to gather feedback quickly, respond to the feedback and adapt. And it's that, do that and repeat, and keep doing that in small steps with AI and guide it, steer it.
And don't
It's
let it have too many permissions. All of the hilarious fail stories that we've seen about AI are about overscoped permissions.
It's all about having confidence in the process of taking code into production.
Yeah.
If your processes are set up to give you that confidence, your AI will hopefully be okay as well. But if you haven't had that confidence before, if you push the button or it runs automatically and you hope for the best, you're likely going to endure some chaos.
I think there's an intriguing idea. I'm sorry. I think there's an intriguing idea in relation to what we've already talked about it employing the good or the bad, is that what that does is it makes your choices even more important, because you're going to dig a hole and create a big mess really fast if your practices aren't good. And you're going to be flying, you're going to be creating good stuff really fast if your practices are good. And that's increasing the differentiation. There was enough slack in the system in the past where, without being too rude about too many organizations, average kind of barely adequate performance was survivable. I don't think that's going to last very long. I don't think that average or, barely adequate performance is going to be a disaster, I think.
But
I think that, sorry, go ahead, Sean.
Okay, no, thanks. I'll quickly add, I think also that the fact that humans used to be a bottleneck, and that actually allowed us the opportunity to catch up with things that could go wrong. The process was slow, and so there was an opportunity to spot things that went wrong. But as AI takes over some of these tasks and automates it, the acceleration is there, and it doesn't give us the opportunity to interrupt it through human observation, and so the systems are even more important.
Yeah,
And
absolutely.
yeah,
Sorry.
I was going to say that one of the things that I think we've learned is that, we used to be able to do heroic human intervention. There used to be like that one person who could save a bad deploy and hit the stop button. And robots are not going to pull the end on cord. They do not have the capability to say, like, stop, this is not okay.
Okay. Is that a problem? Do we need human bottlenecks because code is going too fast now?
I
don't
I
think
don't think
so.
that human bottlenecks are fast enough for that to work. So I
Mhm.
think we have to automate those things. We've got to. I think this is a fundamental change. To be honest, if typing code was your bottleneck in the past, you were doing it wrong anyway, because that's not the hard part. The hard part is understanding the problem and verifying that your solution fits the problem, and all those kinds of things is much harder than just the typing, just the translation into code. It means if that was the slow bit, you weren't very good at writing code, in my view. So so we've optimized to speed up the bit that wasn't really the problem. And then we've left all the bits that were really the problem, and they're still there, and they can't keep up with the writing of the code now. So I spoke to somebody not very long ago who reckoned that he was producing on his own 12,000 lines of code a day with agentic assistance. Who on earth can honestly review 12,000 lines of code a day? I can't.
Did we
Not
need
and
that?
understand it.
Did his company, we've always said, I think lines of code is the only interesting metric is to measure complexity in your company. We've know lines of code is a bad metric.
Yeah.
Do we want individual teammates writing 12,000 lines of code or overseeing AI doing it?
No, but all of the company, not all of the companies. I apologize because Jean is representing one of some of these companies that are talking about agentic programming tools are certainly pushing that message that this is valuable, generating code fast. Developing software fast is what matters. How fast it writes the code is secondary, it seems to me. And so I want to be able to build software faster. I think that's great. And I can using agentic assistance when I'm doing the right things. But if I'm sloppy, it creates crap really fast.
Yeah, I want to talk to our respectfully baby startup in the room. Jean, what percentage of your startup's code is written by AI?
Would hazard that it's confidently, I would say probably 99%.
Hmm.
And that's not because we're reckless and stuff, but we've very early on, tried to adapt to what does the new world look like. We're still figuring it out. Internally, we're just as confused as everybody else out there. We in our engineering meeting the other day, we had a conversation. It's like we see people talking about running 15, 20 agents in parallel, and we're like, but I can't do that.
Yeah.
And then you have engineers thinking like they're lesser engineers because they can't run that many in parallel. But the reality is, you as a human cannot have that much of a split focus and deliver quality work. And I think what a lot of people, talk about is, they might have a bunch of things running in the background, doing small little things and so on. But, in my own experience, I find that, two, maximum three topics at a time I can focus on. And so I think, there's a lot of falseness out there, people, looking for attention, companies wanting to, kind of like make big statements because it's in their interest for people to adopt their techniques or products. But I think, the reality is we're all still learning and we're at the beginning of this. Nobody that tells you for certain they know the future of what engineering looks like really speaks from experience.
But we're in May, so a lot of people, probably 4 or 5 million at least, people graduated with engineering degrees. What do they do with that? How do it's always been a flawed system where it's been a bit too much greenfield. But if you were advising, as many of our listeners are advising, hopefully, junior engineers, because I think we all agree that you can't have senior engineers without junior engineers, so we need them in the industry. It's probably the least welcoming time for them. So what should they work on right now? What skill sets are they not being taught in slow curricula?
I think, it is probably the hardest time that I can remember in my career for junior engineers, because there's this expectation of things need to move fast and nobody has patience for anything anymore. And what you as a junior need is people to make themselves available to share their knowledge with you. Now, you can hope for the ideal, or you can make the most of what the reality is. And in these LLMs, you can get a good teacher as well. You can tweak its system prompt to make sure that it explains things to you and it doesn't just do it. Ask questions and don't let the LLM implement it for you, but do it yourself until you understand it. I think the trap is that as a junior engineer, you're going to think that the AI is going to do everything for you. It's not going to
I don't think that's just junior engineers.
That's not going to teach you the judgment and the taste kind of like skills you need to learn to know what is the right thing to do, because the LLM will confidently tell you what it thinks is the right thing to do. But do you know when to push back? And that unfortunately happens through experience, and that experience I mostly gained through other people, whether it was code reviews or kind of like listening to talks or whatever, and just team members sharing their experience. And so it's a very unwelcoming environment at the moment where businesses are under pressure to prove that AI can accelerate them. They need to justify their AI spending. And so it creates a hostile environment for juniors. And so I do feel like there's a message in the industry coming up. We got to slow down as well. It's not as loud as the voices of those who say, we got to move fast. But yeah, it's a tough time, but you cannot be despondent about it. The reality is, yes, we need junior engineers because they are tomorrow's senior engineers. But they're going to have to adapt to the new reality and not just rely on the organic transfer of knowledge that used to happen in companies. If you're working remotely as a junior, it's even harder because you can't just tap somebody on the shoulder to ask them a question. So yes, tough environment, but it is possible. You just have to approach it differently.
Heidi?
I think that one of the things that we always should have been teaching, and this is my bias, is we need to teach them to write better. I think that prompt writing is a skill, and that maybe that's a thing we should concentrate on. Like Dave says, how do you know you're getting what you want? How do you write a test for an agentic system? Like, can you get it to prove that it's doing the thing that you asked for? Okay, did you ask for it right? Or did you, sort of hand wave and it assumed the middle of the bell curve when you wanted something out on the edges? So I think that it's very interesting to see how many people lean on LLMs for their writing when writing is a very sophisticated form of thinking. And we need that thinking to understand what we're trying to make.
I agree with everything everybody else has said so far, very much. But I just want to take a slightly different angle on it. I I think this is a horrible problem because, as Jean and Heidi said, you know, certainly we and people before us and since us, we learned by doing the things, writing code, writing lots of code, making mistakes, learning from the mistakes, and figuring out what works better. That's certainly the way that I learned how to do things. And we are. I would agree with what Jean said earlier. Is that when I'm using, it's been a while since I wrote any code. I still occasionally write a code. I do it for examples to show other people what code looks like. And I do it for fun because I like writing code. But I don't do it for production. If I'm doing production, the AI writes the code. I think that if we're not already past it, we are at a tipping point where humans don't write code anymore. I think that's where we are. And I think that people that are saying you've got to review it and understand all of the code does and all that sort of things, I think they're wrong. I don't any more than, when high-level languages came in, we used to look at the assembler that was generated and say, is it doing the right things? How often do you do that? We don't care anymore. That's gone. The code is generated. So programming has taken this step in abstraction. So if you perceive yourself, and part of our problem that we're in as an industry is that most juniors start off perceiving themselves this way. If you perceive yourself as your job being to write code rather than to solve problems with code, then that's where you see the difficult part is that's where you see your skills. And I don't think there are. So I think that the best thing that juniors can do is look other places for where to apply their skills, their technical thinking. And I think that there's I would call it engineering thinking, but there's something about the way in which an engineer decomposes a problem, thinks about how to carve a problem up, what these are, thinks about the ways in which things can go wrong and the corner cases and those kinds of things, and analyzes in a disciplined technical way all of these things. And those are the things that we have to prompt the AIs with, because if you don't, they'll just write crap that won't work. So we've got to specify things, like this. You've got to think, you need to have the kind of mind where you're going to think about those. You've got to understand the problem that you're trying to solve really well, and you've got to be able to work through the problem and learn bit by bit, step by step by step, what the surface area of the problem is that you're dealing with, and communicate that to the AI that's then going to generate the code. And you do this by specifying, creating executable specifications, tests, if you like, that specify what it needs to do, and then how you will evaluate that happened, and those kinds of techniques. But those sorts of skills, I think, are going to be in very short supply. So if I was advising a junior now, I would say try and figure out how to learn those skills fast. I would say you can't go far wrong by learning how BDD works, and think about that as a specification language. Think about that as the way of telling what your AI is meant to do. And I think that will put you on the right track, I think.
So let's loop back and say BDD is behavior driven development. Like, what do you want as an outcome? Not how it gets there, but what do you want to have happen? Yeah. And that kind of thinking is going to be so vital. And it is something that we used to reserve for sort of mid-level engineers. Like, you didn't get to do BDD until you had done grunt work on, like, how do I make this work at all?
Okay. We have some questions from the audience that are excellent follow-ups. I'm going to take the more recent from Greg, and then we're going to go into the reviewing of it all, because that is the bottleneck with AI, and we have a bunch of questions for that. But Greg says, do we need to fundamentally change how we teach people software development? We always did. How much effort they should be putting into learning to code, programming language, syntax. I would venture to say something we haven't talked about, but this is the problem with open source always anyway, the domination of the English language. And is that going to bias people that aren't native English speakers or as compelling writers as those of us in this digital room? Yes, I think we all agree we need to fundamentally change how we teach software development. How?
Go
ahead.
Sorry, go ahead, please.
Okay. I think that it's very interesting. I was talking to a couple juniors last week, and they're like, oh, our CS professor is so old-fashioned. She's teaching us like Java. And I'm like, oh, Java was what they were teaching when I was in college, which was quite a while ago. And I'm like, actually, it doesn't matter. What matters is that you learn that you can affect how a computer behaves, that you know how to structure something so that it communicates with the computer, and that you understand how to make a small change and see the result. Like, I learned to code HTML with a program called Hotdog Pro, which had the beautiful advantage of you didn't have to compile. You didn't compile HTML, but whatever. You didn't have to upload it. It would show you in real time what change you were making so that you could see. I think that's what we need, is like the ability to say like this piece of code changing does this thing, which is BDD, but we haven't really been explicitly teaching that.
Like a new way of abstraction, but tied to business goals, to your end users?
Yeah. It's not just business goals, I think, but it's what the behaviors are that you want of the system. But I think that what we are seeing, what I am seeing in the way that I use AI assistants, anyway, and I'm doing things, is genuinely a step to a kind of fifth generation language. So this is kind of programming at a genuinely different level of abstraction. If you think about the way in which regular programming worked, kind of weirdly, in with the benefit of hindsight, was that we concentrated less on the problem that we're trying to solve and more on the solution that we were trying to solve it with. So the solution was often kind of implicit. It kind of wasn't called out anywhere very much. If you were very good, you might have some tests that said something about the solution. But other than that, sorry, about the problem, but the solution itself was the code, and that was the deep focus. That's gone. So now what we're talking about is absolutely specifying the behaviors that we want of this system. I want to make a game. I want, when the bullet hits this thing, that thing blows up and this thing goes off the screen or whatever else. I'm going to describe the behaviors that I want of the system. But in addition to that, there are other kinds of behaviors that we as technical people are probably the only people that will be thinking about. And you'll say, so, okay, I'm going to think about, it's a big deal when people are doing the same thing at the same time. So if there's another player going on at the same time, what does that mean in terms of the way that things interact? What if that person fires a bullet and this person fires a bullet at the same time? Is that going to break or anything? I want to think about those sorts of things, because concurrency is a complicated thing. If I'm building, so let's move away from games, because I'm starting to struggle with my analogies. But if I'm building a bookshop or something like this, what happens if the book's out of stock? Those are business problems, but they're also technical problems. What happens if there are too many people trying to work with it at the same time? How are we going to deal with those sorts of cases? We need to figure out all of those sorts of behaviors, and that's a mix of understanding the behavior of the system and what we classically have talked about as kind of the architecture and the design of the system. So we need to worry about that stuff too, and we need to think about how can I compartmentalize this so that my AI assistant doesn't go crazy and do something mad. So I still want a modular system. I still want to be able to change it easily when I learn more and get things wrong. I don't want the AI coming in and breaking everything. I still want to be able to validate that I've got all of the things that I had before when it makes a change, because now I'm not relying on the code anymore, because it's probably going to change more of the code than I expect when I ask it to change things. So all of these things, those are the kind of engineering disciplines that seem at the core of what we're doing now.
And we didn't talk security or anything like that, but does that mean that like the agent should by default self-check that it's not leaking private
information? So I think it will help if it does a bit, but we've got to think about that as well. We've got to think about those risks. We can't rely on those things, but those are also behaviors of the system. So I want it to be secure. I want to make sure that when I pay by credit card, my credit card isn't leaked onto the dark web and and killed.
Okay, so we know one of the biggest problems is reviewing all this code because it's exponential. So we have actually two questions that kind of touch each other on this from fabulous but anonymous attendees. So thank you for your questions. Someone said they're very interested in the agentic review loop. Assuming we have strong CI/CD practices and observability and the rest, a lot of companies don't still, but it seems that the big gap is the review loop. What's stopping us from YOLO, you only live once mode? How do we enable humans in the loop reviews? How can we keep someone saying, yeah, it's good to go, while opening that bottleneck up a bit? And then as the other question is, if humans can't keep up with reviewing all the AI code, which it's impossible, then how can we verify that the right decisions are being made? For example, architectural decisions that are consistent with the existing, So how do we make sure the answers, what we're releasing is right? and good, especially if you're not writing code anymore. How can you know what good code is?
Yeah, so this was a conversation I had with another engineer earlier this week. So I feel like I've got it loaded in my context window. Um, I I think the role or the function of code review needs to change. Our tools are not geared to facilitate the new reality that we live with. And our process and the expectations that we've placed on individuals for code review isn't scaling. You cannot keep up with the amount of code an AI can produce. And not just that, there's a psychological component to it when I look at a PR with a lot of that's going to take me 30, 40 minutes to properly review, but I know it took another person 5 minutes to generate. There's an inequality in terms of the effort that goes into that, and that makes me less desirable to engage with it in that manner. Something that we've been experimenting with at Kilo is pushing more of the responsibility of correctness and ownership to the PR author. And that doing basic things like, you're expected to run AI code reviews as you develop locally even, and yes, we have an AI code reviewer that runs on the PR and, it will pick up a lot of issues. But what we're not expecting, the code reviewer to do anymore is, read the code line for line, load the whole context up because it's too much and it's too fast to do all of that. And so through things like our PR templates, where we're asking the author to specify, how did you verify this? Add some screenshots or a walkthrough video of the feature. And obviously what the role of the reviewer moves to a higher level then. It's more like, is this even the right solution to the problem? One of my favorite things to add in my PR description is, what was the problem and how does this PR solve it? Because as a code reviewer coming in now, I think that's the most important thing you can look for is this the right solution to the problem? Is the problem understood correctly? Yeah, is this even the right problem? And then, through domain expertise and understanding of an existing system, look at it, is this architecturally the right way we want to go? Does this match the systems we have and processes we have in our business? And so I think that the function of the reviewer is changing. The sad thing about it is that code reviews was a great way to learn about things. And now that we're seemingly engaging less with the content of it, it takes away some of that learning and sharing of knowledge in the system. But I think, through better tooling and more normalization of what code review looks like in the world of agentic engineering, we can still get to being able to understand and learn and share knowledge through code reviews even.
Absolutely. We have another question that I really love because I've heard, I love the idea of what's happening to team size. The interesting, maybe it's my bias is not a code writer, though nobody will be now, but maybe it's my moment. But the idea that the most interesting changes, and I think this is the lead dev audience and us all, are not technical. It's the people and processes to respond. And Paul brings up a great point. And I asked the room, what do you think the future of pairing and mobbing practices are now that an agent is another and probably the only driver in the group? I don't think it should be the only, but we'll see. As an advocate of pair programming as a review process, as sometime harness for test-driven development and crucially a knowledge sharer, I'm seeing my team default more to working with an agent as a pairing partner rather than another human. I mean, I call it throubling now. I think there can be agents involved, but two humans is definitely how to learn, especially when we have that gap of maybe a junior senior pairing, which juniors may be more comfortable with the AI, maybe too comfortable in things. But how are you seeing these like traditional agile processes adapting?
So I certainly don't think that there's any barrier to the value of pairing along with the AI. You get the AI. It feels a little bit closer to mobbing in some ways, as somebody said, because the the AI is doing the actual code generation, but I've done that a few times where I've paired with people as we discussed the problem and had some good results. I think that works well. And as you said, that's a good way of learning, spreading knowledge amongst the team, working together. I think that works effectively. And I think I've long been thinking that pull request models for code review were second best anyway, and I still think that they still are. So they lag too much. That we want that conversation at the moment when we need that conversation, not a few hours later. So pairing's good. It puts us in the right place. I recognize when people started saying that working with AI assistants, probably a couple of years ago now, started saying that working with AI assistants was like pairing. I didn't see it. That's not how it felt to me. They felt like smart complete to me at that stage. But now they are. Now working with an agent, I use Claude mostly when I'm programming. Working with Claude, I feel like I'm working with a slightly weird person. It feels like that. And that's a good thing from my point of view, that it feels like a collaborative effort on our part. It does a bunch of things that I don't do, and I do a bunch of things that it doesn't do, and together we get a better result. So I'm okay with that too. But I think that pairing is a good use of time and maybe part of the solution for what we do about the junior problem, because the junior problem's a serious one, because we're going to run out of seniors really soon. At the rate that things are going, that there's not much hiring of juniors going on at the moment in many parts of the industry. That's not a good thing.
I think one of my big hesitations about AI is its non-deterministic nature.
Yeah.
Humans are also non-deterministic, so it's not like they're perfect at reviewing code and they might give you different feedback on the same PR on different days. But for learning purposes, it seems to me that I want something that will be predictable. And honestly, for all purposes, like the ideation, everything, that's fine. But I find it distressing to think about differing things going out without me realizing that they're different. And I think that's why I'm AI hesitant, is because like I don't trust it. And I think that one of the things that we can do with pairing is say like, hey, you gave me a different answer last time. Why?
Hmm.
Because sometimes it's like, I don't know, I pulled a different part of the context window. And sometimes it's, well, it's 50-50, could go either way. In either of those cases, it's useful to know, like, okay, there's another route or there's another reason I'm doing this. So I think that pairing with an AI does get you like it's a very sophisticated rubber duck. It makes you say things out loud. It makes you understand your assumptions. But also it allows you to, it's very agreeable. And I think for me, AI would be more useful if it were less agreeable, if it were a little more opinionated.
Have you asked
Because
it to be antagonistic?
well, if I make it antagonistic, then it's just a dick. Um,
It is trained on the internet.
it is trained on the internet, but I'm like, I want what I want from it is like an opinionated personality that will, because that's the thing about pairing is like, why are we doing it that way? What's the point of that? How could we do that differently? That that collegial push is a large part of how we learn from pairing, I think. And AI is, it rolls over too fast. It's like, oh, you're right.
Okay, as we wind down, let's just think about, we're mainly speaking to the engineering managers and future engineering managers on this call. What advice do you have for them in this time?
I give them a piece of personal advice rather than career advice, which is if you're the kind of engineering manager that hasn't written any code for a little while, go and write some code with an AI because it's so much fun. It's so easy.
Yeah, I'll echo what Dave says. You got to get hands-on with this code. The worst thing you can do is to try and lead people, but not have empathy for what they're going through at the moment. Whether it's the doubts, the uncertainty, the frustration of swearing at an LLM because it confidently does something stupid, you have to experience that with them to be able to lead from a position of authenticity, but also to make good decisions. You're going to get pressure from up top potentially to, do AI strategies and stuff. And, there's an expectation to 10x your productivity because this is what this person said. Or, but you have to be in the trenches and experience these things so that you can have informed conversations and share from your own battle scars, what it is like to adopt to agentic engineering. And feel where things are moving faster. Where are the bottlenecks? Where do you suffer? Where's your process not working well? And you have to get hands-on, not to be on the critical path of feature development or anything like that, or not to relive your glory days as an IC, but really to kind of like get this experience. The shift is big enough that you cannot rely on your old kind of like experiences as a programmer.
Hire for communication skills and not code skills. The ability to explain not only to an AI, but to your coworkers what you're trying to do is even more important than it always was.
And study yourself, take a Toastmasters course or something, but I blame a lot on engineering leadership not understanding how they connect to business goals because it stops with them and they need to advocate for their teams. And you probably actually have budget to do all the continuous integration and deployment. Just say it's part of AI. That's the best advice. If you say it's part of AI, you may get the budget for it finally.
It's quite good at doing some of it for you if you ask it well.
Just always check and trust your teams. Keep that door or Slack huddle open. And we'll continue the conversation in Slack. We had some more questions. And thank you so much, Jean, Heidi, and Dave. And thank you, listeners. Good luck out there. We really seem, I would say, more optimistic than I thought we would be.
Thank you all for attending.
Bye, everyone.
Thank you.